Okay, so this is a connections of factoring to calculus video, and what I've done here is put up a couple examples of how factoring plays into calculus 1, and because we know that the calculus really doesn't present much of a problem, but what does present a problem are some of the elementary algebra skills that atrophy and then result in becoming a problem in Calculus 1. So what I did here was put up an exercise that might come out of a calculus question, and namely a product rule that might have been done. So we've got 5 times the quantity x squared plus 4 to the fourth power times 2x times the quantity x minus 2 to the fourth power plus x squared plus 4 to the fifth power times 4 times x minus 2 to the third power. And so if you want to, just stop the video at this point and work through the exercise. And then once you think you get to the point that it would be completely factored, uh, turn this back on and check your answer. So I'll give you a second to stop the video and try to do this factorization. Okay, so what do you see here? Well, you obviously see some common quantities between the two parts of the expression, namely x squared plus 4 to the fourth and x minus 2 to the fourth. We have an x squared plus 4 to the fifth here and an x minus 2 to the third there. So we have some common elements there. Additionally, we have a factor of 2 that appears in both pieces. The 2x here, and of course the 4 over here. So step 1 would be to factor out those common elements, and that's what you're seeing done here. And again, when we factor, we're dividing. So we factored out a 2 present there and present there. And we factored out x squared plus 4 to the fourth power. And again, remember, when you see a common element, you want to factor it out the lowest power number of times. And so we factor out x squared plus 4 to the fourth. And then finally, x minus 2 to the third power factored out. Now, when you factor that out, each of these terms you have to look at dividing out those things. And so the 5 would remain in this first part of this expression, and the x would remain. And you would have an x minus 2 now to the first power. No need to write that 1 there. You would have an x minus 2 to the first power, and of course x squared plus 4 to the fourth is going to be gone, because when you divide that out, it's going to be a multiple of 1. After the plus sign, we factored out a 2, so 4 divided by 2, there'll be a 2 remaining in that term. And the x squared plus 4 to the fourth was factored out, so x squared plus 4 to the fifth divided by x squared plus 4 to the fourth leaves you with x squared plus 4 to the first power. No need to write that 1. Now, our next step, we do the algebra in here, and all that amounted to was a distributive property. And so we have 5x squared minus 10x plus 2x squared plus 8 by doing that distributive property. And then as you combine the like terms in there, the 5x squared and the 2x squared is the 7x squared, and the minus 10x to the plus 8. All right. Then you wonder, can this expression right in here be factored any further? And if you take a look at it by virtue of the AC method that was discussed this week, then the AC method, the 7 times the 8 gives us 56. So then all the factors of 56, we have 1 and 56, we have 2 and 28, we have 4 and 14, and we have 8 times 7, and those are all the factors of 56. And we compare them to the b value, and the b value is 10. And at first, you might think that the 4 and the 14 gives you promise for factoring this expression. But as it turns out, that won't work, because both signs are negative. In other words, if you were going to factor this quantity, you would have to have, what the sign language is telling us is we'd have two minuses. The signs are the same, that is to say. And 4 and 14, with signs being the same, that's going to produce an 18 instead of a 10. And so the 7x squared minus 10x plus 8 is algebraically prime expression, and so there's no further factorization to do. So that's an example of how factoring plays into the product rule in the calculus. Now, I've put up another example here, and side by side with the problem, over here you're seeing the final answer. So again, if you'd like to at this point, you can stop the video and see if you can do the algebra of factoring this expression to get to this final answer over here. So if you want to do that, it's 1/2 x to the minus 1/2 power times the quantity 3x plus 4 to the 1/2 plus 3/2 x to the positive 1/2 power times again the quantity 3x plus 4 but to the negative 1/2 power. So if you want to stop the video at this time and go ahead and try to do the factorization and see if you can come up with this final answer over here. And then when you come back, you can check your work, and I'll show you the rest of it by restarting the video. So take a minute and do that if you like. Okay. Um, Working this exercise, again, just like we did with the nice integer exponents, here we have fractional exponents. And so we look for common base elements. And right away we see that both things, both quantities, are multiples of 1/2. And so we'll factor out a 1/2. You also see that they're both multiples of x. And of course, you have x to the minus 1/2 and you have x to the positive 1/2. And the rule we reminded you this week, factor out the lowest power you see. So we're going to factor out x to the minus 1/2. And similarly, with the 3x plus 4 to the 1/2 belonging to both items, both terms, we're going to factor out 3x plus 4 to the minus 1/2. Now, of course, the first expression, uh, not difficult, 1/2 divided by 1/2, it's going to give you a 1. The x to the minus 1/2 being factored out, you divide x to the minus 1/2 divided by x to the minus 1/2, that's going to give you a multiple of 1. Make sure you understand how when 3x plus 4 to the 1/2 is divided by 3x plus 4 to the minus 1/2, you would subtract those exponents, as we mentioned in a video earlier this week. It's a 1/2 minus minus 1/2 is going to result in a factor of 3x plus 4 to the first power. No real need to write that 1 there. And then the second term, very similar. We factored out 1/2. 1/2 divided by 3/2 is going to give you a factor of 3. And the x to the 1/2 divided by x to the minus 1/2 results in just an x to the first. And of course, the 3x plus 4 to the minus 1/2 was factored out. So we continue, and we do the algebra of the bracketed set of the bracketed set of the situation here, and we get 6x because 3x plus 3x is 6x plus 4, and at that point you should see a factor of 2. So we factor out that 2 out of this 6x plus 4, and then this 1/2, since this is all multiplication, times this 2, those two are going to become a 1. Okay. Now, finally, what we did with the negative exponents, we used what's called the 1 over rule. And that basically says that if you have x to some negative power, that's equivalent to 1 over x to the a. Now, later in the 7 weeks, we'll be working with exponents, but it cropped up here. And so just to remind you, if you have something to a negative power, you can change the sign of the exponent by moving a multiplied term from a numerator to a denominator. And that's exactly what happened here. This is x to the negative 1/2 times 3x plus 4 to the negative 1/2 times 3x plus 2. So we left the 3x plus 2 in the numerator and removed the x to the minus 1/2 to the denominator, so it now has a positive exponent. And likewise, the 3x plus 4 to the minus 1/2 is now in the denominator as with a positive exponent. Finally, it's also noteworthy, I think, when you have an algebraic expression like this, you don't want to divide by 0. And so we would exclude 0 from the domain of this situation. Um, and 0 would be a number we'd be very concerned about when doing a calculus exercise. And likewise, if you think about when could 3x plus 4 be equal to 0, that would often be a consideration. And pretty simply solved, that gives us x equals negative 4/3 would be another number that we'd be concerned about in the calculus. And if you want to look at when the whole expression is equal to 0, that would be when the numerator is a 0, and so you have x equals negative 2/3 there. So there's an example of how factoring extends into the calculus and how you want to be well practiced at factoring so that basic algebra skills don't get in the way of you being successful in calculus. So try the Unit 1 test, and we'll see you later.